How quantum computers will change the world. Level B1. Intermediate. When people hear the words quantum computer, they often imagine something like science fiction. They picture a machine with bright lights, strange symbols, and unbelievable power. They hear that quantum computers will solve problems in seconds that normal computers would need thousands of years to solve. It sounds like magic. But quantum computers are not magic. They are real machines, built in real laboratories. They are still young and difficult to use, but they are improving. And even though we are not yet in a world where everyone has a quantum computer at home, this technology may change many parts of our future. To understand how, we need to start with one simple question. What makes a quantum computer different? A normal computer uses bits. A bit is a tiny unit of information that is either 0 or 1. Inside your laptop or phone, billions of tiny switches turn on or off. By combining these 0s and 1s, computers can do calculations, store photos, play music, and run games. This system is powerful, and it has changed the world already. A quantum computer uses qubits. A qubit is different because it can be 0, 1, or something in between at the same time. This sounds impossible, but it comes from quantum physics, the science of very small particles. In quantum physics, particles can exist in a special mixed state until we measure them. This is called superposition. Another important idea is entanglement. Entanglement means qubits can be connected in a very strong way. If you change one, the other changes too, even if they are far apart. In a quantum computer, entanglement can help qubits work together like a team, not like separate switches. Because of superposition and entanglement, a quantum computer can explore many possibilities at the same time, which can make it very powerful for certain types of problems. But here is an important point. Quantum computers are not better at everything. They are not a faster version of your laptop for browsing the internet or playing videos. They are special tools for special tasks. Think of them like very advanced calculators for a few difficult problems, not like a replacement for normal computers. So, what kind of problems could quantum computers change? One big area is chemistry and medicine. Many important questions in chemistry are extremely hard for normal computers because molecules are quantum systems. They have many possible states, and the number of possibilities grows very fast. Normal computers can simulate small molecules, but large molecules are very difficult. Quantum computers, in theory, can simulate quantum behavior more naturally. This could help scientists design new materials and new drugs. For example, they could search for better batteries, stronger and lighter materials, or medicines that fit a disease more precisely. Today, developing a new drug can take many years and huge costs. If quantum simulations become good enough, researchers could test more options in the computer before expensive lab experiments. This would not replace real testing, but it could make the early stages faster. Another big area is logistics and optimization. Optimization means finding the best solution among many possible solutions. For example, a company might want the best way to deliver packages to thousands of customers. Airlines want the best schedules. Factories want the best production plans. Cities want the best traffic management. These are not simple problems. When you have many choices, the number of possible solutions becomes enormous. Normal computers can solve many optimization problems, but some are too complex. People use clever methods and approximations, but sometimes the best solution is very hard to find. Quantum computers may help with certain optimization tasks by exploring many possibilities in a new way. If this works, it could make supply chains more efficient, reduce waste, and save time and money. A third area is finance. Financial markets are full of risk, uncertainty, and huge amounts of data. Banks and investment firms already use powerful computers to model risk and plan strategies. Quantum computers might help with some complex calculations in risk modeling and portfolio optimization. Again, this would not mean quantum computers predict the future, but they could help find better strategies under uncertainty. A fourth area is artificial intelligence. People sometimes say quantum computers will make AI much smarter. This might be true in some limited ways, but it is not guaranteed. Some parts of machine learning involve heavy math and optimization. Quantum methods might speed up some tasks, but AI is not only math. It also depends on data, training, and good models. Still, many researchers are exploring quantum machine learning, and in the future, quantum tools could become part of AI systems. Now we come to the most famous topic, cryptography and security. Cryptography is the science of keeping information secret. Many modern security systems, like online banking and private messages, use encryption. Some encryption methods are based on math problems that are very hard for normal computers. One famous example is RSA encryption, which depends on the difficulty of factoring very large numbers. A powerful enough quantum computer could, in theory, break some of these encryption systems much faster than normal computers. This sounds scary because it could affect banks, governments, companies, and personal privacy. But the story is not only fear. The world is already preparing new encryption methods called post-quantum cryptography. These are designed to be safe even against quantum attacks. Also, quantum physics can help create new security methods. There is something called quantum key distribution, QKD, where two people can share a secret key in a way that can reveal if someone is spying. This is not a perfect solution for everything, but it shows that quantum technology can both threaten and improve security. So, yes, quantum computers could change cybersecurity, but it will not happen overnight. Quantum computers need to become much bigger and more stable to break the most important encryption systems. And the world can upgrade security before that happens. This is a race between technology and preparation. Now, if quantum computers are so powerful, why don't we have them everywhere already? The biggest reason is that qubits are very fragile. Quantum states are easy to disturb. Heat, noise, vibrations, and even small changes in the environment can break the quantum state. This is called decoherence. Because of this, many quantum computers need extremely cold temperatures, sometimes close to absolute zero. They also need careful control systems. Another problem is errors. Qubits make mistakes easily. Building a useful quantum computer needs strong error correction. Error correction in quantum systems is much harder than in normal computers. You often need many physical qubits to create one stable logical qubit. This means scaling up is difficult. Because of these challenges, today's quantum computers are still limited. They can do some experiments and special tasks, but they are not yet powerful enough for many real-world uses. This stage is sometimes called the NISQ era, meaning noisy intermediate scale quantum. It's like early airplanes. They can fly, but they are not yet reliable for mass travel. Even so, progress is real. Scientists and engineers are improving qubit quality, increasing qubit numbers, and developing better algorithms. Some companies already offer quantum computers through the cloud, so researchers can test ideas. First, it's important to understand that quantum computers will probably not be a new phone that everyone buys. Most people will not have a quantum computer at home. Quantum machines are expensive, complex, and need special conditions. Instead, quantum computers will likely work like supercomputers today. A small number of powerful machines will exist in labs, big companies, and research centers. People and businesses will access them through the internet, using cloud services. You may use quantum computing without even knowing it, because a company you use might run quantum calculations behind the scenes. So how could this change normal life? One way is through new materials. Many future technologies depend on materials: better batteries, better solar panels, lighter airplanes, and more efficient electronics. Designing materials is hard because atoms and electrons behave in quantum ways. If quantum computers can simulate these systems better, scientists could discover new materials faster. That can lead to products that last longer, use less energy, and work more safely. For example, better batteries could improve electric cars and help store energy from wind and solar power. Stronger and lighter materials could reduce fuel use in transportation. More efficient fertilizers could reduce pollution. These changes might sound indirect, but they can shape the whole economy over time. Many big changes in history came from new materials like steel, plastic, or silicon. Quantum computing could help the next wave. Medicine is another area where people may feel results. If quantum simulations help researchers understand proteins and chemical reactions better, they might design drugs that work more precisely. This could support treatment for diseases that are hard to target today. Again, this will not be instant. Medicine needs testing, safety checks, and time, but quantum tools could speed up early research and reduce expensive trial and error. Next, think about transportation and logistics. The modern world depends on moving goods. Your food, clothes, electronics, and packages travel through long chains. Those supply chains are often inefficient. They waste fuel, time, and money. If quantum algorithms can improve some optimization problems, companies could plan routes, schedules, and storage more efficiently. Even small improvements can be huge at scale. That could lower costs and reduce emissions. Energy systems could also improve. Power grids are complex. They must balance supply and demand every second. Adding renewable energy makes the system even more complicated because wind and solar are not constant. Better optimization can help grids become more stable and efficient. Quantum tools might help with certain calculations, especially for big networks. Now, let's return to cybersecurity, because this is often the loudest topic. People hear quantum computers break encryption, and they imagine a sudden world where all secrets are open. In reality, the change will be slower, but still serious. If large quantum computers become strong enough to break some current encryption, then many systems would need updates. Governments, banks, hospitals, and messaging apps would need to use post-quantum cryptography, which is designed to be safe against quantum attacks. This transition is already happening in many places because it takes time to change global systems. Some experts worry about a harvest now, decrypt later problem. This means an attacker could collect encrypted data today and keep it, hoping to decrypt it years later when quantum computers are stronger. For some data, like old personal messages, that may not matter much. For other data, like government secrets or long-term business plans, it could matter. So quantum computing creates a new reason to modernize security. In the long run, this could be positive. It can push the world to stronger cryptography. It can also support new security methods like quantum communication for special cases. But it will require planning, not panic. Now, what about jobs? Many people worry, will quantum computers take jobs? In the short term, the main impact will be on specialized fields. Quantum computing needs engineers, physicists, software developers, and researchers. It will create jobs in hardware, algorithms, and integration with classical systems. It will also create demand for people who understand both the business side and the science side. At the same time, quantum computing could change some industries by making certain tasks faster. If drug design becomes faster, research teams may work differently. If logistics improves, companies may reorganize. But this is not like automation that replaces millions of workers quickly. Quantum computing is more like a powerful tool for experts. The biggest job effect may be indirect: new products, new industries, and new competition. Education will also change. Today, most students learn classical computing, bits, normal algorithms, and standard programming. In the future, more people may learn basic quantum ideas, at least at a simple level. Not everyone will need to be a quantum scientist, but many tech workers might need to understand what quantum computers can and cannot do. Like AI today, quantum computing may become part of the tech toolbox. Now let's talk about myths, because quantum computing has many myths. Myth 1. Quantum computers will replace normal computers. This is unlikely. Normal computers are excellent for most tasks. Quantum computers are special tools. Most devices will still use classical chips, and quantum will be used only when it makes sense. Myth 2. Quantum computers will solve every problem instantly. No. Quantum speedups exist for certain problems, not for all. Some tasks will remain hard. Some tasks may even be worse on quantum machines. The world will still need smart algorithms, data, and human creativity. Myth 3. Quantum computers are already ready. Not yet. Today's machines are still noisy and limited. Many practical uses need fault-tolerant quantum computers with strong error correction, and that requires much more development. Myth 4. Quantum computing is just theory. Also not true. Real quantum devices exist. They are being tested. The progress is real, even if the biggest promises are still in the future. End quote. So when will quantum computers truly change the world? The honest answer is that change will likely come in stages. The first stage is research and experiments, which is happening now. The second stage is early practical benefits in narrow areas, chemistry simulations, special optimization tasks, and security preparation. The third stage, if it happens, is large-scale, fault-tolerant quantum computing with big real-world impact. No one can guarantee the timeline because it depends on solving hard engineering problems. But even before the biggest machines exist, quantum research is already changing the world in another way. It pushes new science, new measurement tools, and new technologies. Building quantum computers requires extremely precise control of materials, signals, and physics. These advances can create other useful inventions, even outside computing. The final question is what society should do now. The answer is not to fear quantum computing, but to prepare wisely. Governments and companies should modernize encryption. Schools should teach basic digital and scientific literacy. Researchers should work openly and responsibly, and the public should learn the realistic story, not the science fiction story. Quantum computers may not arrive like a sudden explosion. They may arrive like many other technologies, slowly, then faster, and then everywhere in the background. One day, you might benefit from a new medicine, a safer communication system, or a cleaner energy solution, and you won't think about quantum physics at all. But somewhere in the chain, quantum computing might have helped make that future possible.